So what I'm going to do here, I'm on valohai.com right now. I'm just going to create a new account here for myself. I've already logged in, so it takes me to the create new project page. I'm going to take our TensorFlow MNIST example code. Basically, what we have here is we have batch feature extraction as one pipeline step and train as another pipeline steps. These are the only parts that you're interested in. And we have a Valohai YAML file. In the YAML file itself, we've defined two steps. We have batch feature extraction and train model. In the batch feature extraction step, we're basically defining this is the Docker container we want to run this code on. This is the code snippet that's here in GitHub, and this is the command line that we're going to use to run it. The script gets some input data from Amazon S3, and that's basically it. Then we're doing the train model step itself. Again, we're tying it to a specific Docker container just so that every part of your pipeline is always tied to a specific software environment. You can always override this in Valohai as well. So the command for it is itself, we have some parameters, additional parameters that the script here is expecting to get in. And these are fully dynamic and manageable by you. So we, for instance, have in this particular example, we define the max step size, the learning rate, the dropout rate, and so forth. So let's import this project into Valohai. Let's call, first of all, demo. This is the demo project. We'll go under settings and repository and paste the URL here and just import the project, and we're done. So the first step we want to do is create a new execution. The execution starts usually from, let's take the batch feature extraction. These are the steps from the YAML file that Valohai imported here. We can change the committed code version that we want to use, so we can go with an older version if we wanted. We can choose the environment we want to run it on. We support Azure Cloud, AWS, Google Cloud, or any on-premise hardware. So you can even run it on your own on-premise hardware if you wanted to. We'll just add them here to the combo box. Then we can go ahead and change the Docker image, anything public available, any custom Docker image, we support all of it. You can change the command, you can change the input data and so forth, but I'll just go with the defaults here. I'll create an execution, and what happens here is that Valohai starts up the AWS server. We install the Docker container of your choice, and we start running the script. And what's nice here is that Valohai keeps track and knows which ones are the most used AWS instances or any hardware instances that you have, plus the most used Docker containers. So they have them. So we have them preheated and ready to go. So we're actually done here. This is your script. It ran for this amount of time over here, and we shut down the server. So there's all in all, this step took us 22 seconds. Compared to, for instance, if you had SSH into an AWS server, set up a Docker container and started running your scripts there and so forth, it would have taken a significantly longer time. What Valohai does here as well, we have some outputs. So in the batch feature extraction step, we exported some images for testing and training purposes, and we have a full log of everything that we've done. So the details on where we ran it, when we ran it, which parameters and so forth is all here. So we did the batch feature extraction. Let's now actually train our artificial neural network. So instead, let's go with the train model step. Same things again. We can select how to do, where to run the stuff. In this case, which actually, instead of going with the defaults, let's use the training images that we just trained in the batch feature extraction step. And training labels and test images and test labels. And this is again completely configurable by you. This is what the YAML file in your source code dictates that you want as inputs. So whatever your script expects to get, as well as the hyperparameters, that's completely configurable by you. So we can go with these defaults, or we can go ahead and just change, for instance, to this. Let's create an execution. Again, Valohai automatically starts the AWS instance or your on-premise hardware or other cloud provider. It installs the Docker container. We can see that it's already running here. In this particular code, we're outputting something as JSON format to the standard out. So whatever is outputted in JSON format, Valohai can pick up and output it on a graph, so we can actually visually follow the progression of our selected parameters. So whatever we want to have as output parameters that help us make a better decision and when the model is trained and ready to go. So whenever it's ready, it's actually going to output the script, in our case, output stuff to the output folder. In our case, it's going to output the weights and the biases for the model. So we're ready to deploy this next. But the nice part is that say 6 months later, you have this in production. You want to know, how was this trained? You'll have information on everything from source code to Docker image with specific versions of libraries that you happen to have in that Docker image during the time, with data that you trained it on, as well as all the hyperparameters, as well as how long it took you to run the training run. Everything you've seen so far and everything in the entire UI is completely written with an API first approach, meaning that you can do everything here through an API call from your continuous integration environment, or you can do it from the command line, so you wouldn't have to go into the UI at any point. It's just easier to show everything from the UI here. The last thing I want to show you, just a large time saver. I can go ahead and do the same thing again with trainings that I did previously. But let's say I wanted to do a hyperparameters sweep. So let's say I wanted to try these max step sizes as well as these learning rates. In total, this comes out to 12 different executions. If you did this on your local machine, you'd probably do it in a loop, one after each other. In our case, we can run every one of these in parallel and get results a lot faster than doing them after each other. So what Valohai does here for us, it launches 12 different servers, installs the Docker containers, and does everything in parallel. This being a demo account, it's gapped to 5 servers at the same time, but we can follow here in the traffic lights that which ones are starting up, which ones are executing at the moment, and which ones are ready. So it's going to do it in batches of 5, so 5, 5, and the final 2 ones after that. So once Valohai is ready with the runs, it will all the boxes will turn green. We can jump into any one of these and have a look at them. Basically, we'll know all the version controlled things about every training run, have a complete full audit trail of everything we've done, up to the logs, up to the metadata, up to the outputs, the weights and the biases from the model, as well as any kind of nodes that we might have left there. But at the end of the day, we can go ahead and just plot these parts on a graph. We can sort them, for instance, by accuracy, and go ahead and see that, okay, training model number 7, that looks like the best model that we can come up with at this time. So let's go ahead and use that. So at the end of the day, Valohai is for your machine learning orchestration. Just launch up on any server of your choice at the click of a button, hook up your code, your Docker container, or use any of the pre-existing ones, and just keep on running, and you'll have a complete audit trail of everything that you've done previously. At the end of the day, if you have any kinds of questions or thoughts, if you want to have a private demo, just reach out to me at fredu@valohai.com or give me a call. I'll be happy to organize it for you and your company. Thanks for watching this video. I hope you enjoyed it. Leave your questions or comments in the comment section below.